All right, AP, this is sample exercise 4.082. I'm talking about neutralization titrations. So a student carries out an experiment to standardize, meaning determine the exact concentration of, a sodium hydroxide solution. To do this, the student weighs out a 1.3009 gram sample of potassium hydrogen phthalate. That's KHC8H4O4, often abbreviated as KHP. So KHP is a molar mass of 204.22 grams per mole. Again, you could have calculated that on your own. It has one acidic hydrogen, meaning when it dissociates in solution, it's going to produce one hydrogen. The other four hydrogens do not dissociate. They do not participate in the the acidic nature of this particular compound. So the student dissolves the KHP in distilled water. He adds phenolphthalein as an indicator and titrates the resulting solution with the sodium hydroxide solution to the phenolphthalein endpoint. The difference between the final and initial burette readings indicates that 41.20 milliliters of the sodium hydroxide solution is required to react exactly with the 1.3009 grams of KHP. Calculate the concentration of the sodium hydroxide solution. Go ahead and press pause now, because here comes the solution. So an aqueous sodium hydroxide contains the sodium plus 1 ion and the hydroxide minus 1 ions. The potassium hydrogen phthalate dissolves into water to give a sodium plus 1 and a hydrogen phthalate minus 1 ion. As the titration proceeds, the mixed solution contains the following ions. We have the K plus 1, we have the phthalate minus 1, hydrogen phthalate minus 1, and the sodium plus 1, as well as the hydroxide minus 1. The OH minus 1 will remove an H plus 1 from the HC8H4O4 minus ion, the hydrogen phthalate, to give the following net ionic equation. We have the hydrogen phthalate minus 1 in the aqueous phase plus the OH in the OH minus in the aqueous phase to form H2O in the liquid state and phthalate in the aqueous state. Since the reaction exhibits a one-to-one stoichiometry, we know that 4.120 milliliters of sodium hydroxide solution must contain exactly the same number of moles of OH minus as there are of the hydrogen phthalate ion in 1.3009 grams of potassium hydrogen phthalate. So we calculate the moles of potassium hydrogen phthalate in the usual way. We take the 1.3009 grams of potassium hydrogen phthalate, and then we convert that gram value into a mole value using the molar mass of that particular substance. In this case, it yields 6.3701 times 10 to the negative 3 moles of that potassium hydrogen phthalate. This means that 6.3701 times 10 to the negative 3 moles of OH must be added to react with the 6.3701 times 10 to the 3 moles of hydrogen phthalate. Thus, 41.20 moles, aka 4.120 times 10 to the negative 2 liters, right? Because when we do our molarity calculations, liters is going to be best for us, of the sodium hydroxide solution must contain 6.3701 times 10 to the negative 3 moles of OH minus and, sodium plus 1. And the concentration of the sodium hydroxide solution is, we take the moles of sodium hydroxide and we divide it by the liters of solution. And so we have the moles of sodium hydroxide, which is equal to the moles of the potassium hydrogen phthalate, because they occur at a 1-to-1 ratio. And then the the liters of the solution, 4.120 times 10 to the negative 2 liters, which is 41.20 milliliters represented as liters. This represents a molarity of 0.1546 molar.